states of the agent world. So how we define and how we see and look into it. So we will try to demonstrate some of these aspects, right? So how can we represent the world that supports the making of the models, right? So there are these are the different increasing fidelity states which we have to see and look into, right? So there are atomic states, which is basically acting as a black box with no internal structure. So that's the first type of states of the agent world. The second state is your factored stage, wherein you have a list of vectors, basically which provides the attributes which helps you to make any kind of real values, right? So your vector of attributes made up of the Boolean, real valued, or one of the fixed type of states. So these are the factored state. The most sophisticated state, as we call that, as a structured state, basically made up of the object which could have its own attributes. So let's talk about typical agent functionality. So if you refer about the functionality which agent should have, we expect that the agent should be able to manage few of these functionality. So given any kind of inner agent representation to the world, we want the agent should be able to do the planning part. The agent should be good in planning the activities. So whenever any kind of external percept come across, the agent should be able to carry out the planning based on the external percept which is there. The second typical functionality is the overall searching part. So if we have AI agent who's working on any kind of scenario, which is like a multi-agent game or any kind of game of choices, such as rolling any kind of dices, or if you are in an environment where you have to find the best route, or if you are doing any kind of navigation. So the searching part is one of the important functionality which agent should be able to carry out successfully. The third typical functionality which we want agent should be able to manage well is the natural language processing. So we want AI agent should be good in managing the natural language processing. So the input at times can also be received by external set of individuals or humans which will give the command in form of natural language processing. So the agent should be able to process it as well. Agent should have representing knowledge which is required for carrying out the tasks which is given across to him or given across to it, and agent should be able to make decisions effectively. So some of those scenarios can be fed into the agent, but then typically if there are newer set of things which is given across, the decision making has to be enabled based on the kind of experience which it has gained over a period of time. That's the expectation of and the functionality which is typically expected from an agent. And the next important functionality is learning from examples. Based on the past experience, based on the past scenarios, the agent should be able to learn from them, and it should be able to carry out the perception part of it. So that's how we always consider the AI agent or the machine learning agent should be able to tie up all these features and functionality to ensure that they are working in a effective manner. So these are the important functionality which has to be imbibed in the agents. So now let's try to discuss what is the state of art. So these are few of the scenarios. So if you refer to the robotic vehicles, so there are few vehicles which has been now rolled out wherein there is no, or we call that as a manless vehicle, wherein you need not to have anyone required for driving those vehicles. We call that as robotic vehicles. So that is one of the examples, several examples of state of the art functionality, as we call. So those robotic vehicles uh, have been tested across the world, and those robotic vehicles are also used in various missions across the world and outside the world to find the life. So any unmanned mission by NASA and other space organizations, they use those elements of robotic vehicles. The second state of art functionality, as we call, is the speech recognition. So your agent or your AI or machine learning based agent should be able to carry out the speech recognition features or functionality. The third important state of the art element is your autonomous planning and scheduling. So your agents should be able to carry out any kind of planning or any kind of scheduling of functioning based on the kind of inputs which it receives. It is expected that if any agent is being part of any scenario planning, they should be able to carry out those game planning activities as well. So that is again one of the typical state of the art example of AI agent. So in case of the general usage, if you see in enterprises, we use spam filtering, which is again one of the example of state of the art, wherein most of the emails get filtered across based on the kind of rules which is put across in those AI agents. So anything, any email which is unsuspected or which is not the right domain, then it moves in a different folder. So that's how we try to do the spam filtering for your email functionality. Similarly, some of the logistic planning in supply chain can be handled through the state-of-the-art features and functionality of AI agents. Robotics is another one of the viewpoint wherein the state-of-the-art functionality can be explored as well. And there are other examples of video, audio, and text-to-type conversions wherein your agents can be used for these. So we call that as a machine translation. So as we now call the autonomy of the AI agent and the overall robotics part of it, we always say a truly rational agent certainly has to be autonomous in nature. So it has to be self-propelled, it has to be self-learning, it should learn to make up for any kind of incompleteness of information around it. So all the scenarios, all the environment which is there around the agent might not be 100% complete. So your truly rational agent should be able to perform some of those tasks based on the incompleteness or incorrect information which is around the robotic agent or environment. So an agent which basically lacks autonomy, it will rely on the prior knowledge from the designer. So if the agent is not autonomous and if it doesn't have that capability, then it will try to do a search based on the prior knowledge, based on the prior database, and that's how we try to take actions based on that. So that's how your agent which is not autonomous might not be able to carry out each task in a flawless manner. But certainly there need to be some kind of prior knowledge to get going. So anything and everything cannot be fed into the agent, but then there has to be a basic starting point. So there has to be a initial condition which has to be put across so that the agent can start building on top of it. So as we say, an autonomous robot can start acting on its own, and we call and we say individuals are or humans are thinking, is it a point of concern for humans? It's too early to comment. Is it really safe for humans that, now if the agents become too much autonomous, is it a threat to humans? It's too early to comment and talk and discuss about this point at this point in time.